All right. So yeah, hi everyone. This is just like the tutorial we're doing for Tinkercad to just show you how the components work. So right here, I just have a circuit diagram of just like the Arduino and the breadboard, along with the power rail and ground connected to the corresponding rails. Um, so then now I'm going to connect a servo motor. So right here on the right toggle, I can just scroll down and select the servo motor, or I can just search up servo, and then it will come up. It will come up here, and I can drag that onto here. So if you kind of just drag, like hover over these, it'll tell you like what each pin does. So since this first one's connected to ground, I'm just going to have a wire connected from here going into the ground rail and then make that black. And then since this one is for power, I'm also going to have this wire go like this and have that connected to power as well. So you can see, it's a little hard to see, but this one's connected to ground. And then this one over here is connected to power. And then finally, we want the Arduino to be able to communicate to the servo motor. So we're going to take this one right here and connect it to one of our digital pins. So we're just going to choose 3 and we'll make this blue. It's right here. Okay, so now everything's connected with that. So then now we're going to move on onto the LEDs. So the LEDs, we're going to utilize the columns. So as Varsha mentioned earlier, all these rows are connected together, or these rows are connected together. So anything I connect here will all be connected in unison. And we're going to use a resistor, and we're going to have one of the legs be connected to ground, kind of like this. And then recall that, recall that like the longer end of the LED, which is kind of this bent one, is the one that has to be connected to power. So we're going to drag one of these wires onto the power rail, and then we'll make this red. And as we and now that like this is connected, we remember we want this to talk to the Arduino. So we're going to take another wire right here, and we're going to connect it to pin 8, and we'll just make this purple. Okay, so that is the LED, and then we also have the other 2 LEDs that we want to connect. One's going to be a yellow one, and then we're going to have another one for green. So we're just going to follow the same procedure as we did before. Oh, and then one thing I forgot to mention is that this resistor, you can change its how many resistances or the resistance of it. So in this case, we want 220. That's just kind of like a standard resistance that's used for like the LEDs. So if you ever buy an Arduino kit, typically it will come with some resistors with like 220 or 270, I believe. And then this is in kilo ohms, and we want to just change that to ohms. And now we're just going to do the same thing for the rest of them. We'll connect the resistor for here, and then a resistor for here. Make sure that they're all connected to ground. And then we're going to, like this should be like this. And then we're going to connect all of these to power. So we'll make that red. It's just nice to also like color your wires, because as you come up with more complicated circuits, you'll find it's a lot easier to identify what wires go to what components. So that's just something to keep in mind. And then we're going to connect this wire right here to digital 9. We'll name this yellow, and then we'll connect this one to 10. Make that a little nicer. Okay, so that's kind of like the structure of the LEDs. And then now we're going to connect the potentiometer. So the potentiometer is right here. So we can just drag this over here. Okay, and then so for the potentiometer, this wiper is just kind of the pin that connects to the Arduino that has it. That's basically where that's basically receiving input from the Arduino or like from the potentiometer. Okay, so this pin, recall that the potentiometer is an analog, so we can control this potentiometer ourselves. And then depending on what this potentiometer reads, it will read it to the Arduino and then control another component. So we're going to take this wire and we're going to drag it all the way down to one of the analog pins, which is A0. And then we'll just have that one be turquoise. And then this first one is power. Wait, Varsha, is it power or ground?
The negative rail?
Yeah, this one's power, right? Or, or yeah, okay, yeah. So yeah, this one's power. And then this one is ground. So we'll have this one be black. And then, yeah, that is how you would wire up these components. And then once you've wired up everything, if you go up to this toggle up here, this is code. And then you might not have, if you have this set to like blocks, you could just change this to text. I already did that here. And then this is like the code here that runs the simulation that I showed you in the previous circuit. So we're just going to go through some of the code and explain it to you. This code will also be offered to you guys in case you want to try running this yourself. So to start off, in an Arduino, there's essentially three things we have to do. The first one is like your setup stage where you define all of your inputs. So like this is where I would define my LEDs, my potentiometer, and my servo motor. The setup is where I would declare what my components are doing. So for example, if I have an LED here, this is an output, since the Arduino is telling the LED to do something. So as you can see, like right here, this is an output. I'll explain this more in detail later. Or you can declare something as an input. So like, for example, this potentiometer is an input since I'm going to be able to vary this on my own and the Arduino is going to have to read that. So kind of those factors we define here in the setup. And then the loop is basically like the meat of your code. It's basically what the user wants the Arduino to do. And this is like where all that logic that I explained to you earlier is going to be presented, but in code. So that's kind of a quick overview. So to start off, we're going to start off with the initial section. So one thing just to keep in mind is that some of these components have like individual code for them, um, that can be really complicated to code yourself. However, like one of the nice things about Arduino is that it comes with these things that are called libraries, which is what you see up here. Essentially, what a library does is it comes with a bunch of functions that you can use yourself, that basically make interacting with a component easier. Because if the Arduino didn't come with those libraries, then the coding can become really difficult. So the servo motor has some of these libraries. So that's why you see this include servo at the top. And if you're working in the IDE, so like if you're working on the actual Arduino, so like for example, wait, can you guys see this screen? No? Okay. Well, I'll explain this a little bit later. But yeah, essentially this is just some extra code that's used for the servo that allows you to easily interface with it. And then the second step is to go into the variables. So I'm going to start off with the LEDs. So the first one is going to be this one up here. So I call this hashtag define green and then 10. So essentially what this means is I am creating a variable green that I want to control this green LED here, and I am assigning it to 10. And the reason I'm assigning this to 10 is because if you notice, I connected the green LED to digital pin 10. And the reason I did this is just so later on in my code, instead of having to type in 10 and like remind myself what pin I connected this to, it would just, I can just type in green. So like when I run this code, this compiler is going to look at the word green and interpret it as 10. Um, so if, so I guess I can ask you guys some questions. Like, so in this case, if I wanted to define the red and yellow pin, how would I go about that? If anyone wants to just type in the chat. Wait, I can't see the chat actually, Varsha, so you'd have to check.
I got it. Oh, why does it say -10 on the board in the digital section?
Oh, okay. Yeah. I didn't go too much into detail about this, but if I'll just briefly explain this. So if you can see right here, this is the digital section, and then there's this little thing right here that's called PWM. So PWM stands for pulse width modulation. Essentially, what that does is it's sending frequencies to the LED. You can think of this as like turning the LED on and off, but extremely fast. And since you're turning the since you're powering or like sending these frequencies to the LEDs super fast, I can decide like how fast I want like those frequencies to be sent to the LED. And like you might be wondering like why would I want to turn on and off like an LED rapidly, like in ways that I can't see. The reason you would do that is because you can actually control the brightness of the LED by controlling how fast it turns on and off. And so I can make the LED look a little bit dimmer if I send these on and off signals really fast to the LED. And since the human eye can't like see an LED turn on and off super fast, then to me it just looks dimmer. I'm not sure if that made any sense or if that answered your question, but that's just kind of like what PWM does. And like we'll probably go into depth more into some other like into later workshops, but that's just so you know. So it's not a negative sign. It just means that these pins in specifically can support PWM. Because if I connected it to pin 8 and I wanted to do PWM, it wouldn't work.
Thank you for the explanation. I had a follow-up question. So since pin 8 doesn't have the dash next to it, how come for 2 of our LEDs we're using PWM enabled digital pins, but not for the red LED?
Oh, you can use any pins for like any of the LEDs. It doesn't matter if it's PWM or not. The dash just means that if I wanted to use PWM on the LED, I can.
Okay, thank you.
Okay, all right, thank you, no problem. If anyone else has any questions, just feel free to stop me at any time.
We have hashtag define red 8 for the next line of code.
Yeah, that would be, yes, that is correct. Good job. Yeah, since this pin is connected to 8, you would just define it as red 8. So great job. And then you can probably figure out what yellow would be. It would just be define yellow 9. So that is how you would essentially tell the Arduino, or like this is essentially what you would be doing just to like define your variables for the LEDs. However, this servo motor is a bit more complicated than that. So if you recall, I mentioned to you that like the servo motor has this like included library. So since we have this like library here, and this library has certain amount, it has like functions inside of it. And the reason this is here is because I can like create different sort like objects and control different components. So like right here, this is an Arduino. I mean, sorry, this is a servo motor. I can have multiple servo motors and like control them separately with like using a library. So like right here in this line, I have servo. So this is kind of the name of the library. So servo. So these things match. And I can call this servo whatever I want. So in this case, I just called it Myservo. And I can also technically have like another line called servo and have it called like this servo, and then that would just be like a different servo. So I can for example, I can like go into the toggle here, have put this servo in, and then have this servo be controlled as this servo and this servo as my servo. I know that's a little complicated, and if you haven't taken any coding, that might be a little bit confusing as to why it would be defined this way. But just for like your information, just know that this is how the servo is defined. And then the second thing is now we want to define our, well, does anyone have any questions about this specific section? I know that was kind of a lot to unpack if you've haven't seen this before. Okay, cool. But if anyone has any questions, just let me know. So far we've defined the LEDs and the servo. So moving on to the potentiometer. The potentiometer is it's essentially the same way as we defined the LEDs, but since we connected it to an analog pin, we just define it as pot pin, which is just for shorthand for potentiometer pin, and then A0. And then one more step that we have to do is we define another variable for the potentiometer, because if you recall, this potentiometer can move. So the Arduino needs a way of holding those values, different values as we rotate this potentiometer. So we're going to define an integer and then call it pot, and then assign it a value of 0. This value can change. So like, for example, right now, this potentiometer is at 0. So like right now, if the Arduino were to read this, it would read 0. But then if I were to rotate this all the way around to 180, then this integer would change to 180. So yeah, that's just an extra thing we have to do for the potentiometer. One more thing to note is that for hashtag define green 10, I could have also used integer green equals 10. That would essentially be the same thing. But using this define function basically makes it that the variable green can't change. So its value cannot be varied in the code. And it also doesn't take a lot of memory either in the system, but you don't need to worry too much about that. But that's just for your information. And then moving on to the setup. So now we want to tell the Arduino what is our component doing. Are we giving it an input, or are we receiving something from it? So the function that we use for that is pin mode. So pin mode has two inputs. The first one, as you can see, is green. So like this green would mean 10 for in terms of the digital pins. And then in all capital letters, we put output. So that just essentially means that the Arduino is outputting a signal to the green LED. And then we would do the similar things with yellow and red. And then the last part is this section right here, Myservo.attach3. So going again to the servo motor, we created an object that's called Myservo. And now, as I mentioned to you before, this library contains a lot of functions that are used to control this specific servo motor. And one of them is attach. So you use this notation um, to like, in order to use the different functions that are available in this library. And you would use like this dot notation, so dot attach. So now the Arduino knows that, okay, I'm referring to my servo, which is this servo in specific. I am putting a dot. So like now I'm waiting for, so the Arduino's like, okay, what do you want me to do now? And then attach is the function. And attach essentially just attaches digital pin 3 to the servo. So that's why there is a 3 here. And that is the setup and the initializing of the variables. Does anyone have any questions about any of these topics that I just discussed? Okay, cool. So then now Varsha is going to move into the loop.
Okay, so thanks, Chris. So now that we got everything set up, so now everything's like ready for us to use, but we got to figure out what we want to do with all the different components that we have. So first of all, inside our loop, we have pot is equal to analog read pot pin. So if we wanted to figure out what that does, so like over here, we see analog read. So we know that since our potentiometer is an input, we have to read from it in some form. So this analog read function is what allows us to read from the potentiometer pin. So we're reading a value from it, which tells us, oh, this is how much I want to turn, and we're storing it in this pot variable. And then we got to figure out, okay, so now we have this value from the potentiometer. So like, it could mean the potentiometer is over here, or it could be the potentiometer is over here. But now we need to figure out, what do we want to do with it? So we know we want, as we twist this potentiometer, we want our servo to also rotate. So the potentiometer and the servo both have different ranges at which they can rotate. The potentiometer is analog and it ranges from 0 to 1023. So that's like over here. And that's because it can tell like how much voltage is going to that pin. So like if you don't have that much voltage, you'll be over here. But then as you increase the voltage, you're going to go all the way here. And it'll go from 0 to 1023. But then the servo operates in degrees and it goes up to this point. So like, what do you think the range of the servo would be? Like if it goes from here to here? Yeah, exactly. It would be 0 to 180. So we're just using this map function to map the range of the potentiometer to the range of our servo. So that way, when we send the signal, it understands, okay, whatever I do from 0 to 1023, I want that to translate to the range on our servo. So that's what the map function does. And then now that we have stored like this map, like in our pot variable, we want to write it to the servo. So now we got some input using analog read from the potentiometer, and we've converted it into something that the servo will understand. And now we want to tell the servo, okay, rotate by that much. So using our, since we created some variables, we can say Myservo dot write, which is the function for writing to our servo. So we're just taking the value and we're writing that to our servo. So that's like the little translation from the potentiometer, twisting it to getting our servo to rotate. So does anyone have any questions about the potentiometer or the servo? Okay, feel free to stop me anytime or drop it in chat also. So next we're gonna, remember we were talking about how we wanted it to turn the green LED on when we twisted it up to here, but then when we twisted it up to here, we wanted it to turn on yellow, and when we twisted it up to here, we wanted to turn on red. So like for different twists on the potentiometer, we wanted different LEDs to turn on. So that's where logic comes in. So first, before we code anything, we have to figure out what we want to do with our logic. So let's look at an example for green. So we're using an if statement. So we're just saying if our potentiometer reads less than, or this plot variable has less than 60. So remember we mapped everything in terms of the servo. So that means if we're at less than 60 degrees, we want the green LED to be high. So that's our goal. So if we simulated this and we rotated this, whenever we're less than 60 degrees, so whenever we're somewhere over here, or somewhere over here, our pot, we're going to turn our green LED on. So if we go back to, Chris, is this the old one? Okay, I'm going to start simulation. And so in this region from 0 to 60, so up to this point, we have our, we went over. Our green LED is on. Okay, there we go. So up to 60 degrees, our green LED is on. So that's where we told it to do that. So we're saying if it's less than 60 degrees, digital write our green LED to high. And when you write something to high, you're basically saying turn it on. So we're sending our voltage to this green LED. So that's what digital write does. And then why do we have an else statement? Why are we saying if it's not, we want to write it to low? So let's go back to our thing over here. So if we're not within 60 degrees, so say we're over here. So if we're over here, only the yellow is on. So that means our green is turned off. So if we aren't within that 60-degree range, we only want the other LED on. So that means our green LED should be off. So that's why we write green to low. So we want it to be off once we're in a different range. So if we wanted to do something similar, for the yellow LED, how do you think we would write our code? What would be our if? Over here we have if less than 60 as a range. What would be our range for the yellow LED? So I'll go back here and we can look at what the yellow LED does. Feel free to drop things in chat also. 60 to 120. Okay, nice. Exactly. Yeah, exactly. And how do you think you would write that in this kind of format? Like, so that's exactly the right range. Awesome. And so over here, how do you think we would write that? I'll give you a clue. If you want to write less than or equal to, you can always just put an equal to over there. Okay, nice, nice, nice. Okay, awesome. Yeah, so you would use, and what are those ands that you have in the middle? What are they for? Yeah, exactly. Because here you have two conditions. You want it to be greater than 60, but you also want it to be less than 120. So you got to make sure it works for both of those conditions. So exactly what Annalise said, if your potentiometer is greater than or equal to 60 and it has to be less than 120. So that's how you would write the condition for your yellow LED. And what do you think we would do for the red LED? That's our last range. How would you write the if condition for that one? Do you think we would write greater than, or would we have an and here also? Like, would we say if pot is greater? Exactly, exactly. Yeah, if it's greater than or equal to 120. Exactly. So we don't need to include that 180 at the end of our range because we know that it's going to stop. That's anything greater than 120, we want it to go up to that for the red. Exactly. And so those will be our conditions. And then we would be able to use the same code for all of those. So like if that condition, we would turn it on high to make sure the LED is turned on, but else we would want it to be off. So then you would have three of these. So, oops, I just moved that by accident. Yes, you would have three of these for each of your, one for each of your LEDs. So that's kind of the logic behind the code. So using the ranges from our servo in order to write our LEDs to on or off. And then we also have a delay over here. So this delay is just so that instead of having our LED work really slow or really fast, if we want to change up the speed, we can use a delay. And you can change the number of seconds or like how long you want your delay for. So whenever you feel like something is going too slow or too fast, you can try out a delay to fix that. So that's kind of the logic of the code. I know we did a lot of explaining and like looking at how things work. So we have like a little activity sort of thing that you can try out. So we will send this code and also the comments with it. So if you want to try doing it on your own, you can do that. And we also have the slides. I will go back to the slides so that we can, let me pull that up. Okay, let's pull this up. All right. And also feel free to type in chat if you have any questions or ask them out loud. Okay, but here is our little challenge activity. So this is something that you can do after today's workshop. It's based on all the concepts that we worked on today. And also, if you ever have any questions, we're available on Discord for you to text us any questions that you may have, and we can work with you on that. So the little challenge is if you have an Arduino at home, you can do this using your Arduino. But if you're doing this on Tinkercad, you can also do it on Tinkercad. It works on both. So you can make a little cardboard person or character who kind of acts like a traffic signal operator. So basically, based on if the LED, so whenever your LED is green, you want your flag to be up. And whenever like people need to slow down, you turn it to be horizontal. And when you want it to be, when you want them to stop, you turn the LED red. So you can make this using a cardboard figure and your own Arduino and Servo. Or if you make this on Tinkercad, you can import a CAD figure, which we can link when we share these. So also think of what different applications you can use with some of the components we learned. On, if you like Google servo projects, you'll see a lot of projects with the servo. So that's a good place to practice. And we'll be here to help out. So does anyone have any questions? Oh, I see chat. Okay. But yes, this is a little intro to Arduino and using like LEDs, servos, and the potentiometer. And I know this can be daunting, especially if this is your first time using Arduino. I know it definitely was for me, so feel free to message us anytime if you have any questions. Because how do you feel about it? How are you feeling about Arduino? Okay, nice. Yay, okay, cool.
That's always good to hear.
All right, that's awesome. And let me, and I think there is, and also if you missed the link to Tinkercad, I'll link it again in case you guys want to try it out. It's really cool. You can use it to test like many different kinds of circuit components, but you can also use it for like 3D modeling in CAD and stuff. So a lot of different uses for it. So and also if you don't want to make a big circuit, even when you have a real Arduino, you can always simulate it on Tinkercad. So that way you don't run into a lot of issues first while wiring everything up. But yeah, this is the link to Tinkercad. And I will also link the IEEE Discord, which is where we have channels for the workshops, and people are asking questions in those channels. So if you ever have any questions, feel free to message on there also. All right. Expires never, and I will send it. Okay. I put this.
Yeah, you should be able to have access to the slides, right? Yeah, and one of the slides at the end also has like a slide with like a lot of the functions that we described in case you like forget what they mean. So you can always check that out.
If no one has any questions, thank you all for coming. Yes, this is, and also IEEE is doing IEEE Startup Center and Coffee and DSC are collaborating for a lot of these kinds of workshops. So feel free to drop in any of the workshops. And also, if you want to get your own Arduino kit with a lot of components, IEEE is sending out these project kits. So there's a project proposal link that we've shared on the Discord, and you just need to fill it out and like basically what you're interested in doing and just a little about what you want to work on it with, and you could get your own Arduino kit to work on. So if you want some hands-on stuff during this virtual time, Arduino is a super fun thing to try out. But yes, thank you for coming.